Hey everybody, it is Mr. Canfield, and we are going to go over our trig review for chapter 4. Oh wow, do I sound as tired as I am? Alright, let's see, we're going to cross out the word not here. So, this is the honors version of the review, and I am doing the CP version of the review. So let's see. First things first, CP gets rid of this question. CP also gets rid of this question. This and this are over 13. This and this are over 17. And then let's see, find the values of the 6. Okay, so this, crossing that off. And then, boom, crossing that off. Number 16, sketch. So we're not going to sketch, but we are going to find out all the information about these. And we're going to do 2 sketches. Oh wait, and then we're getting rid of 19 to 21 because we didn't graph tangent. All right. And then we didn't learn these, so we're not doing those. Okay. So, purposes of that is to, if you weren't here or forgot, we're not doing those. Okay, so evaluate sine of 180. So we're going to need a unit circle to do this. Now mine, I printed it out, but we need to be able to do this perfectly. So you can, if you're not sure, I'm going to blame Albert on this because it was his idea. You could always somehow get this onto your note card, and then, you know, that'd work. Or you could remember how to do it. So, or somewhere in between. All right, so let's see. Evaluate sine of 180. So we go to 180, boom, and we have to remember, what does sine do? Well, sine is the y coordinate. So since our y coordinate is 0 there, sine of 180 is 0. All right. Evaluate cosine of 3 pi over 2. All right, let's see. 3 pi over 2. 3 pi over 2. Cosine is our x coordinate, so cosine of 3 pi over 2 is 0. Then, let's see, evaluate tangent of 11 pi over 6. All right, let's see. So we got to find 11 pi over 6. Boom. Tangent says take sine divided by cosine. So sine divided by cosine. So sine was -1/2. Cosine was √3 over 2. So then if I'm going to find those, well, I got to keep change flip, and I'll get -1/2 times 2 over √3, which is -1 over √3. And so, as far as the answer goes, that is correct, but now we have to get it in the right format. And the way we do that is oh wow, powerful yawn, I'm so sorry. We multiply the top and bottom by that square root of the bottom, and so it's called rationalizing the denominator. So we get square root of 3 on the top with a negative still there, and then 2 radicals cancel each other out, and we're just left with the number that was inside, so just a 3. So again, -1 over √3 is correct, and then -√3 over 3 is the better format. Let's see, cotangent of 210. So we'll find 210, cotangent. So we remember that tangent was sine divided by cosine. So cotangent, the flip of that, will be cosine divided by sine. And so we're going to do -√3 over 2 divided by -1/2. We'll keep change flip, so that's -√3 over 2 times -2 over 1. Now those 2's are going to cancel again, and a negative times a negative is going to equal a positive. And we could put that over 1, or we leave it like that. All right, let's see. Evaluate the secant of 2 pi over 3. So we'll go to 2 pi over 3, secant. Secant has to do with cosine. Remember that secant, cosine, they don't start with the same letter. So secant goes with cosine, and cosecant goes with sine. Just remember that they can never go with the same letter. They never start with the same letter. So if I find this, the cosine of 2 pi over 3, that's right here. Let's see, cosine's the x coordinate. That's -1/2. The secant's just a flip of it. So that -1/2 turns into -2 over 1. You could write over 1. Let's see. Sine of 30. Oh, I never yawn this much on camera. I'm so sorry. let's see, 30 degrees, 1/2. So sine of 1/2 is, so sine of 30 is 1/2. That means that if we flip it, we get 2. All right. Oh, I have been doing these out of order. Oh well. Convert pi over 18 to degrees. So this was where we had a formula for this. And the idea was I want to use dimensional analysis. And if I'm starting out in radians, that means that I want to cancel out radians. So I know that pi will cancel out radians. And what's the equivalent of pi? Well, I can use this to remind myself that pi and 180 are equal to each other. They're at the same place. So if I do pi over 18 times 180 over pi, I will get, let's see, and the pi's cancel, and we get 180 over 18, and we can figure this out. This is equal to 10. And so similarly, if I'm taking 720 and trying to convert that to radians, I want to cancel out the degrees. So this time I'm going to divide by the 180 and then times pi. And if we do 720 divided by 180, we get 4. And so we wind up getting 4 pi here. So, all right. So that is basically the end of what was unit circle-y that we're going to be needing. But I'm going to hold on to it just in case I'm forgetting something. All right, let's see. Determine the exact values of the 6 trig functions of the indicated angle. Okay, so here's our angle. We've got 5 and we've got 13. So like, I gotta label the sides. Let's see, here's my right angle. So I know the right angle always points to the hypotenuse. And then the side that's touching the angle, so the hypotenuse touches the angle, and the other side that's touching it is also called the adjacent. So, because it's adjacent to the angle. And that's a Josh Elrod trick for you right there. Then the other side is the opposite. So my personal way of remembering that was that wherever the angle is, the one across from it is called the opposite. The one that's opposite it is called the opposite. I don't know the adjacent side. I'm going to need that. So if you know your Pythagorean triples, then this is easy, but let's just pretend we don't. So I could say if a squared plus b squared is equal to c squared, and I need to remember, let's see, the hypotenuse is always c, and then a and b don't really matter as long as they're legs. So I'll say a squared plus 5 squared. Well, all right, so let's see, let's do this. A squared and then 5 squared is 25. And then 13 squared is 169. So now I'll subtract the 25 from both sides. I'll get a squared is equal to 144. Take the square root of both sides and get a is equal to 12. All right, so that's 12. So if I'm trying to find the sine, cosine, and tangent of this, I can just use SOHCAHTOA. It says I want all 6, but I really just need these 3. And if I have these 3, I know the other 3. I just flip them upside down. So let's see. Sine is opposite over hypotenuse. Opposite over, so 5. So let's see. Sine of our angle is 5 over 13. And then cosine of our angle is adjacent over hypotenuse, so 12 over 13. And tangent of our, oops, I wrote TOA. Tangent of our angle is opposite over adjacent, so 5 over 12. Then I'm going to have to flip all these, and I already know the answers to these. I just have to remember their names. So if I want to remember the names of these, well, I've told myself a bunch of times that they never start with the same letter. So I know that this S can't start with an S over here. It has to start with a C, and that's CSC. Cosine is secant. Again, starts with a C. That one starts with an S. Tangent. Tangent's the only one that's like, well, duh, that's its flip. Tangent's flip is cotangent. All we did was literally flip them upside down. We flipped them upside down, wrote them over here, changed the name, hooray. Then I'm going to draw one of these. His eye looks like a 6. That's a problem. Let's try again. There. Oh, missing a nose. Okay. Oh, missing hands. Oh, missing feet. Oh, All right, anyway, so let's keep going. Let's see, we're skipping this one. Determine the exact values of the 6 trig functions of the angle. So if we want to do this on this unit circle question, we know x and y, that's the same as cosine and sine. So I could say that cosine of theta is equal to 12 over 13, and sine of theta is equal to negative 5 over 13. Now I'm writing sine above cosine because this is, for my brain, I like to put sine first, then cosine. It's just, it's an aesthetic preference. It's not, there's no correctness or anything about it. All right, last one, tangent's not as simple. So tangent, I'll need to use this and I'll go, okay, tangent, let's take sine divided by cosine. So it's negative 5 over 13 divided by 12 over 13. And if we keep change flip on that, then that's negative 5 over 13 times 13 over 12. We have a 13 on the top and a 13 on the bottom. Remember when we multiply across? Those 13s are just going to cancel. And we're going to be left with negative 5/12. Hard work's over. Now it's just a matter of remembering their names. So cotangent, cosine flips to secant, and sine flips to cosecant. All right, cool. Oh, I forgot my squiggly in the middle. There we go. There's my squiggly. If you're watching this video and this has been helpful for you, you're going to write a secret code on the top of your test. And if I find out that you're sharing it with people, like just saying, "Oh, you gotta write this code at the top of the test," well, then nobody gets it. So it's a secret. It's the secret code. The secret code that you're going to write at the top of the test is, Mr. Canfield, may I have bonus points? So what's going to happen is, like, there's going to be this spot for your name. You write your name here. You know, let's say you write your name as Dr. Mr. Fun. Like, let's say your name was Dr. Mr. Fun. Well, then above that you say, Mr. Canfield, may I have bonus points? Then you'll see a little +2 over that. But that's just between you and me, okay? I don't want to find out that everyone's doing this. Well, if I see people writing the wrong thing, if I see people saying, can I have bonus points? Or I want to put the secret code here. No, that doesn't count. So you might want to write that on your note card if you want those bonus points. Anyway, okay, so enough for that. Determine the exact values of the 6 trig functions of this angle. So it's more of the same, just another example. So in this one, our sine is negative 15 over 17. Our cosine is negative 8 over 17. And our tangent, so I already know what the tangent is going to be because those 17s are going to cancel. It's just going to be the sine number over the cosine number. But I don't want to skip those steps because this is supposed to be the helping video. So that's negative 15 over 17 times negative 17 over 8. Remember, a negative times a negative is a positive, so those are going to cancel each other out. And so will the 17s, and we'll be left with 15 over 8. And then we'll have some flippity-flippin' action. So remember that a negative upside down is still a negative. So as we're careful with these flippin' flips, see, sine turns into cosecant, cosine turns into secant, and tangent turns into cotangent. All right. So that's that. Let's keep going. Let's see this next one. We want to talk about the amplitude. We want to talk about the period. We're going to talk about the horizontal shift, and we're going to talk about the vertical shift. So that's the thing that I'm going to be focusing on with all of these. And maybe I'll just go through and do the amplitude for all of them first. So remember, amplitude is always this first number, except when it's negative. So in number 17, it's a negative 3 over 2. Amplitude is still just 3 over 2. Because amplitude is how high we are off of the middle of the wave. It doesn't matter if the wave is upside down or not, because it's still bouncing back and forth like this. So even if it goes down first, it's still coming up. It's about how far away from the middle we're getting. So this amplitude is 3. All right. Now let's talk about horizontal shift or phase shift. So that has to do with when there's a plus or minus inside the parentheses. So out of these three, we need to edit this last question. This is going to be 2 parentheses x minus pi. We did not discuss this minute difference in class. Don't lose sleep over it, it's fine. So the only one of these with a phase shift is number 18. It has the x minus pi. That means it moves to the right pi. All right, now let's talk about vertical shift. The only one of these with a vertical shift is our last one, and it goes up 1. Remember that vertical shift, has everything to do with if there's a number being added onto the end. If there's not a number being added onto the end like that, there's no vertical shift. All right, period. This is the difficult one. This is where we have to find the coefficient on x inside the parentheses. So in this case, the coefficient is 1/4. In this case, the coefficient is pi. And in this case, the coefficient is 2. And we always do the same thing. We take 2 pi and we divide it by that coefficient. 2 pi divided by that coefficient. 2 pi divided by that coefficient. So 2 pi divided by 1/4. Keep change, flip that, you wind up getting 8 pi. This one, 2 pi divided by pi, the pi's cancel, and we just get 2. And then this one, 2 pi divided by 2, the 2's cancel, and we get pi. So literally, that's the procedure for that. That's the way we do it. Then state the domain and range of these. Now, we never actually talked about tangent in class together, so we're gonna so domain and range, we need to talk about this. This is important for us to talk about later, but just to keep things simple for now. State the domain and range of this. Well, remember that the way the inverses work are the domain and range get flip-flopped from the original ones. So I know the original sign has a domain of all real numbers. And we cut it off. We cut off the range of inverse. Hold on, let's just, okay, so we know sine of x, its domain is all real numbers, and its range goes from -1 to 1. So inverse sine has this, the -1 to 1 for its domain, and its range is going to be, instead of going from -infinity to infinity, we cut it off and we say from -90 to 90. And inverse cosine's a little different. We're going to have the same domain of -1 to 1, but then its range is going to be from 0. Oh, I should have put brackets around that. To 180. All right, so that's everything that was in the packet. And the one other thing that I said in class that you need to be able to do was graphing. And you need to be able to graph pretty colors. So let me just grab. All right. So I will have the graph set up for you. But I wrote 2 graphs on the board in class. The first graph is sine of x minus pi plus 2. All right. So if I'm going to graph this one, first thing I got to do is I'm going to graph the original sine graph. I'm going to do that in pencil because it's probably the least critical of these, but we need to remember that the sine graph swoops from 0 up to 1, back down to 0, back down to -1, and back up to 0. And that happens every half of pi, which the way that we've done it in class was that was every 3 spaces. So, and you know, I'm not going to throw any curveballs at you. That's the way it's going to be on the test too. So I'm going to use my color code and say OG sine x. Then I'll switch to green for my next one, and I'm going to say, oh, I see that it moves to the right, pi. So that means that each of these points needs to move pi spaces to the right, or pi units to the right, which if you look on our graph, every 6 spaces was a pi. So that means that I'm going to take this and go 1, 2, 3, 4, 5, 6. That got moved over here. Then this one, 1, 2, 3, 4, 5, 6. Now I'm going 6 spaces because that's how many spaces it takes to get from 0 to pi. Then this point, this gray one hiding under here, 1, 2, 3, 4, 5, 6. Then this one down here. 1, 2, and then our last one. 1, 2, 3, 4, 5. Oh, hey. So, if that were to happen on the test, that's not your fault. All right. So I graphed my sine x, moved to the right, and now I'm going to take this, and I'm going to go up 2. So if I go up 2, the thing is, look, every space only counts for a half. So if I want to go up 2, that's 4 whole spaces, right? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Remember that we go from our most recently drawn picture. We don't go back to the original ever again. And that is how we get full credit on one of these. All right, the other one was y equals 2 sine x plus pi over 2 minus 1. All right. All right, let's see. So we'll start with our sine graph. I'll start with the normal pencil again. So ba 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 ba. All right. Remember that, like, you could go forever. I could keep going up, but it's just, we're just doing it once. All right. So that's that. So there's my OG sine. Then I see it's plus this time, so that means that we're moving to the left, pi over 2. Now, how far is pi over 2 on our graph if pi is right here? Well, it's going to be halfway. So there's only going to be 3 spaces. So I'm going to take each of these dots and count 3 spaces to the left. All right, and then I see minus 1. That means go down 1. So I use my most recently drawn picture and count down a 1. Oh, I didn't label this, sorry. That's 1, that's 2, -1, -2. All right. So take each of the green dots, count down a whole 1, which is 2 spaces. Remember, actually, this is good. I missed, but I tried to draw my curve, and I had my dots clearly defined. This is full credit, so. I think the only other thing that would have been good to talk about today is if I had said, if f of x is equal to 3x minus 2, find this. Find the inverse. So if you're working with me and you want to try it out, I would pause the video real quick and make sure you still got the idea. All right, I'm going to go over it in 3, 2, 1. Here we go. So if we want to find the inverse, well, we need to remember this says y is equal to 3x minus 2. The inverse, all you do is anywhere you see a y, you write an x. Anywhere you see an x, you write a y. Everything else stays the same. And all we're trying to do is get y back by itself. So I'll have to add the 2 to both sides here. Get x plus 2 is equal to 3y. Well, and then if I want to get y by itself, I'll just divide both sides by 3. And so I could write this as x plus 2 over 3, or I could write x over 3 plus 2 over 3. In either case, instead of writing y, we're going to write f's inverse. All right, literally it. So, cool. I hope this has been helpful. Yeah, feel free to contact me on Schoology or in person if you have anything about the test. That's it. Yeah. All right. See you guys.